Hello, everyone. This talk is to present our FACT 2022 paper, the Model Card Authoring Toolkit, towards community-centered deliberation-driven AI design. My name is Shen. I am a system scientist at CMU. This is a collaborative work with my co-authors, Leijie, Wesley, Ciell, Ronald, Haiyi from CMU, Tsinghua University, and Dutch Wikipedia. Recently, there have been increasing calls for centering impacted communities in the design of the AI systems that will be deployed in their communities. However, the diverse and sometimes contradictory nature of a community's goals and needs, as well as the inherent model trade-offs, often prevent community members from effective participation. For example, what if reducing false positives will inevitably increasing false negatives? What if increasing overall accuracy can negatively impact system fairness? What if not all community members agree on those system criteria? What if different social groups have different, and in many cases, competing interests in AI design? To address these issues, in this paper, we present the Model Card Authoring Toolkit, a toolkit that supports community members to understand, navigate, and negotiate a spectrum of machine learning models via deliberation and pick the ones that best align with their collective value. Deliberation is at the core of our toolkit. Instead of algorithmically aggregating individuals' preferences for AI design, we argue for the importance of collective decision-making through deliberation. Taken as a group, the toolkit is designed to specifically achieve the following three objectives. First, it aims at helping community members understand the trade-off across multiple community goals on AI design. Second, helping community members discuss and negotiate the trade-offs across a spectrum of machine learning models. Third, helping community members make collective and informed decisions within their specific community context. In this paper, we document an early use of our approach in the Wikipedia community to help them build community values into a machine learning tool called Aurus, which is widely used in many content moderation services in the Wikipedia community. Our toolkit uses three different artifacts: the authoring tool, the comparison table, and the deliberation protocol to scaffold the deliberation process. I will introduce how these tools are being designed and deployed in the Wikipedia context shortly. So basically, on the English version of the Wikipedia, they receive about 160,000 new edits every day, which immediately go live. Wikipedia has built a machine learning-based system called Aurus to access the quality of those edits. Roughly speaking, Aurus gives each edit a score that represents the probability of that edit being damaging. Admins can then determine what threshold to apply to these predictions. One challenge Aurus faces is that it operates in diverse working context and involve multiple stakeholders. There are tensions between different stakeholder values. For the purpose of this study, we focus on two sets of trade-offs between four different sets of system criteria and their respective community values. First, the trade-offs between newcomer protection, that is, minimize false positives and catching all the potential damaging edits, and quality control, that is, minimizing false negatives and not falsely labeling good edits as damaging. Second, the trade-offs between overall accuracy and disparity, that is, treating different editor groups equally. We also illustrate the model impacts on three different editor groups: newcomers, experienced, and anonymous editors. Next, I'm going to introduce how the toolkit is being designed and deployed on Wikipedia. The authoring tool offers an interactive interface describing a range of machine learning models by showing their important performance metrics that reflect the trade-offs across multiple community goals. It allows community members to navigate a spectrum of models and select one that aligns with their values. After model selection, a community member will be asked to write down the rationale behind model selection. The tool will save the model and the rationale for easy sharing. Second, after community members select their models, the comparison table concisely summarizes the key performance metrics of different models and explains their impacts on different groups. It allows community members to systematically and comparatively examine a range of models and scaffold the trade-off discussion. When using the toolkit, the community members will follow the Deliberation Protocol. First, they will have an onboarding session during which they will be briefed about ours, the machine learning services, including background, the purpose, and the functionality. Next, in the discussion session, they will be encouraged to discuss with each other on which model is producing the best outcome. For example, what is the definition of good outcome in their community? What are the pros and cons of different models? Finally, after the discussion, they will be asked to perform a two-step writing task. They will first be asked to summarize and write down the high-level principles that ours should consider to better benefit the Wikipedia community. They will then be asked to write a group proposal about their collectively chosen model. Ours has been designed and deployed in more than 30 different language versions on Wikipedia. Each language version is an independent editor community. Our study focused on two different communities, English and Dutch Wikipedia. We choose those two communities for our case study because they differ in size, editor groups, and content moderation policies, so that we can observe the effectiveness of our toolkit in different types of online communities. We conducted 4 online workshops, 2 with English and 2 with Dutch, using our toolkit. In total, 15 editors participated in our study. Our participants assumed different roles in Wikipedia, including editors, content moderators, patrollers, mentors, admins, and developers. In each workshop, participants were asked to complete a 5-step activity. First, finish a brief pre-survey. Second, use the authoring tool to generate their individual model card. 3, use the comparison table to discuss in groups on which model they would recommend. 4th, write a group proposal about their collectively chosen models. 5th, complete a post-survey. Overall, we found that the use of the toolkit improved participants' understanding of the model trade-offs and enabled them to connect those trade-offs to a wide range of community goals and values. For example, D4 said, "Look, if someone says, I have nothing to do in the next 6 hours, it can take a while and I'll look at it in great detail. Then I choose D1's model. But if I only had 1 hour, I'd choose D2's model. And if I had even less than, I'd choose D3's model." So different people will have different positives or negatives. In both the pre and post survey, we asked our participants about their perceived understanding of, trust towards, satisfaction, and control of our system. Our data has shown that after the workshop, 14 participants' perceived understanding of ours increases, which are consistent with our findings from qualitative studies. We also noticed that the use of the toolkit has helped participants to discuss and negotiate the model trade-offs across multiple design goals. For example, D7 mentioned, "Yes, my initial choice was based on the importance of accuracy and decreasing workload. But now that I hear from you that the admin don't brief this, I would rather choose model 2. Similarly, in both our pre and post survey, we asked our participants about their priorities in maintaining content quality on Wikipedia. we noticed that in the pre-survey, 9 out of 14 tend to consider that maximize overall accuracy as of higher importance, and the editors in general have diverse goals towards AI design. After the workshop, the participants started to change their priorities. In particular, they were less likely to prioritize accuracy. In addition, they have also narrowed down their listed priorities, which suggested a potential convergence of different design goals after our workshop. Finally, we observed that our toolkit has helped participants to make collective decision of ORA's design within their specific community context. For example, D5 asked, so there is an administrative question here, which result do I have? Imagine that we're handling the poodle model. We are starting at the average and then basing our discussion on that. Furthermore, we noticed that our participants have been actively saturating their decision into their own community context. That is, the toolkit helped them go beyond merely choosing a machine learning model, probing them to think more about the purpose of the AI system, as well as the larger community context within which this system is saturated. For example, since the Dutch Wikipedia is a relatively small and homogeneous community, with almost all its members living in the same time zone and interacting with each other both online and offline, some participants questioned the need of deploying a machine learning system. D4 asked, in what capacity is this adding to what is already being done? For example, almost all of us are in the same time zone. If anyone posts anything, say, at 3 a.m. in the morning, we will know this one is problematic, right? Do we really need ORAs? Towards the end of the study, we also noticed some challenges towards the larger research agenda of building a community-centered, deliberation-driven AI design. First, there are time and resource challenges. Sometimes interested community members signed up for the workshop, but eventually didn't make it due to time constraints. This suggests opportunities to conduct alternative type of deliberation. For example, instead of online synchronized workshops, we can also host asynchronous deliberation sessions through Wikipedia's internal forum, such as Village Pump. Second, there are literacy challenges. Although we tried different ways of simplifying the toolkit, our participants still need to spend a fair amount of time trying to understand the terminologies. This suggests opportunities of furthering lowering entry barriers for community-centered AI design. For example, can we provide lightweight interactions to quickly contextualize the terminologies for non-experts? Third, there are also infrastructure challenges. This was especially present in our study with participants from the Global South, since their network connection was very unstable. This reminds us the importance of considering the diverse needs and constraints real-world community members can face in their everyday lives. Finally, the research agenda of community-centered AI design demands long-term, deep engagement with real-world communities, to which our work is just a starting point. Future work is needed to support sustainable participation from a wide range of community members and to actually incorporate their decisions and feedback. This requires new design approaches and mindset to which we hope to contribute in our future studies. Thank you.